Today, we're digging into a really innovative solution for industrial waste. And it's one that was born out of a massive crisis facing one of Canada's biggest economies. You see, Ontario is running out of places to put its trash. And believe me, the clock is ticking. All right, so here's how we're going to break this down. First, we'll look at the problem, what we're calling Ontario's landfill cliff, and see how that's sparking these real-world battles for disposal sites. Then we'll shift gears and introduce the solution, the digital refinery. We're going to look under the hood at the tech, unpack the amazing economics that turn waste into wealth, and finally explore how this whole model could scale up and go global. So let's just set the stage here. We are talking about a fundamental breakdown in a system that we all just take for granted. And for a place like Ontario, this isn't some far-off problem. It is a fast-approaching reality. This right here, this is the central question. It's driving policy, it's driving protests, and it's driving innovation all across the province. It's such a simple question, but the answer is incredibly complex and, frankly, really urgent. This chart really spells out the deadline we're up against. See that yellow line? That's the key. If Ontario loses its access to U.S. landfills, its own capacity is just gone. In about a decade, the province is literally heading for a landfill cliff, and that's forcing everyone to scramble for solutions. And this number just shows you the sheer scale of that dependency. We're talking about 3.44 million tons of waste being trucked across the border every single year. You know, this isn't just a logistics plan. It's a huge geopolitical vulnerability. Any little change in U.S. policy, a new tariff, a border issue, could trigger a full-blown crisis overnight. And this pressure, it's not just theoretical. It's creating these intense, real-world conflicts on the ground as companies and the government desperately search for new places to put all that waste. Just take a look at the town of Dresden. You have a company, York One, that wants to reopen and massively expand a dormant landfill. I mean, we're talking up to 700 trucks a day running 24/7. And to speed the whole thing up, the province used a piece of legislation, Bill 5, to exempt the project from a full environmental review. Well, as you can imagine, this sparked a fierce legal battle and massive pushback from the community. This is what the landfill crisis actually looks like. So with that backdrop of scarcity and conflict, a new idea is starting to emerge. What if we stop thinking about finding more space for our waste and instead we re-engineer the waste itself? This quote right here, it gets to the absolute heart of this idea. It's a complete reframing of the business. The goal isn't just to get rid of something. It's to create something totally new and valuable from what we used to just call trash. You see, the old model is painfully simple. You haul and dump. You collect waste, you truck it somewhere, and you bury it in a hole. The digital refinery flips this completely on its head. It's a refine and monetize strategy. You process the material right there on site, you refine it into valuable commodities, and then you sell them on the open market. Okay, this all sounds great in theory, but how does it actually work? Well, the answer lies in a really cool combination of advanced sorting tech and a well-known chemical process, all packed into a mobile unit. So first things first, what is pyrolysis? Simply put, it's a way of superheating organic material, like wood, but, and this is the key part, without any oxygen. And because it's not actually burning, the material doesn't turn to ash. Instead, it breaks down into its core chemical components, a solid, a liquid, and a gas. But before you can refine anything, you have to know exactly what you're putting in. And this has always been the biggest hurdle in wood recycling. On one side, you have clean, natural wood A. And on the other, you've got wood B, all the stuff with glue, paint, and chemicals, like MDF or treated lumber. If you mix them, you basically ruin the value of your end products. And this is where the digital part of the refinery becomes an absolute game changer. The system uses a combination of near-infrared and X-ray sensors, all powered by a deep learning AI. Think of it like a super smart scanner that's been trained to instantly recognize the unique chemical signatures of everything from the resins in MDF to the metals in treated lumber. It can sort this messy mixed waste stream with a speed and accuracy that was just impossible before at an industrial scale. So once it's sorted, the pure feedstock goes into the pyrolysis unit. And this table, well, this is where the magic happens. You have one input, wood waste, and through that chemical transformation, you get three totally distinct outputs: a solid, called biochar, a liquid, bio-oil, and something called syngas. And every single one of these is a valuable commodity. So now we get to what might be the most compelling part of this whole story, the economics. How does this model not only solve a huge problem, but also create a powerful financial reason to do it? Okay, let's start with the old model. If you're running a business like a timber mill, getting rid of 1 ton of wood waste actually costs you money. Between hauling it away and paying the landfill tipping fees, you're shelling out up to $90 a ton just to make it go away. It is a pure liability on your balance sheet. Now look at the new model. That exact same ton of wood, once it's been refined, can generate anywhere from $200 to over $900 in revenue from selling its byproducts. I mean, this isn't just an improvement, it's a complete economic inversion. A cost becomes a profit center. And the business model is so strong because it captures value on both ends. First, on the input side, the client saves a ton of money by not having to pay landfill fees. Then, on the output side, the refinery sells the biochar, it sells the bio-oil, and it can even use the syngas to help power its own operations, which creates even more savings on energy. And here's the bottom line, all visualized for a big timber mill. The old way meant spending nearly $2 million a year just on waste disposal. By putting this new model in place, they could see a total positive financial swing of $6 to $12 million every year. The business case is just undeniable. So this is clearly a powerful solution for a single company, right? But the vision here is much, much bigger than that. The goal is to create a scalable model that can be deployed pretty much anywhere. And the rollout is planned in 3 very clear phases. First, you validate the technology at a local timber mill and prove it works. Second, you expand into the much more complex world of construction and demolition waste. And finally, phase 3 is to scale it globally by monetizing carbon credits and licensing the core technology to partners all around the world. So we end with this question. This digital refinery model really suggests that for decades, we've been burying incredibly valuable resources in the ground at a huge expense. It forces us to completely reconsider the definition of waste and to start seeing it not as a problem to be disposed of, but as a resource that's just waiting to be refined.